In this video, we're going to explore what happens when inequalities have no solutions or infinitely many solutions. And you might be like, wait, what? I thought all inequalities always had infinitely many solutions. Well, they don't always. They can have no solutions. And also, you could have solutions so that no matter what you plug in, they're true, which is kind of crazy. So let's take a look at two examples of that. We have 14 minus 6n is less than or equal to the quantity 7 minus 3n times 2. Essentially, when you're solving an inequality, you might not be able to tell whether or not we have these special inequalities where there's no solutions or solutions for all numbers that we plug in. And that's okay. It's one of those things you're going to recognize at the end of the problem. So solve it like normal. So we have nothing we can do on the left-hand side to start, but we can distribute on the right-hand side. So I copy 14 minus 6n is less than or equal to, and then I distribute 2 to each term. 2 times 7 is 14. 2 times negative 3 is negative 6n. Okay, so now from here, wait a second. That's the same exact expression on both sides. So I'll keep going one step further, but the same thing is always going to be equal to the same thing. So if I say blah is less than or equal to blah, they're both blah, right? So they're both equal to each other for any n value we plug in. I'll prove it a little further. If we were to add 6n to both sides, just to get the n values together, 9 is 6n plus 6n cancels. You're left with 14. Minus 6n plus 6n cancels. So we're left with the statement 14 is less than or equal to 14. Well, that's true. 14 is always less than or equal to itself, which means no matter what n value we plug in, it will work for this inequality. So there are infinitely many solutions to this inequality. Very rad. Okay, on to number 2, right behind me. So number 2 has 4p plus 3 is greater than 9p plus 6 minus 5p. So nothing I can do on the left-hand side, so I'll copy it down to the next step. 4p plus 3 is greater than, now I can combine like terms here. 9p minus 5p is going to be 4p plus 6. Well, let's keep going a little bit further. I noticed that I can join the p's together, so I'm going to do that solving like it's an equation. I'll subtract 4p from both sides, but a little bit of foresight, looking ahead a little bit, shows us that the p values will cancel on both sides. 4p minus 4p is 0, leaving us with positive 3, is greater than 4p minus 4p, again 0, positive 6. This states that 3 is greater than 6. That's never true. 3 is not more than 6. So there are no solutions. So that means that no matter what we plug in for p from the onset, from the beginning, this inequality cannot be true. There's no value that works for p that makes it a true inequality. Pretty interesting. So the moral of the story here is solve your inequalities like normal, like they're an equation, looking out for the inequality signs to switch if there's a division or multiplication by a negative sign. When you get to the very end, if you have something interesting where you have a true statement with no variable left, then you have infinitely many solutions. If you have a statement that is never true with no variables present, then you have no solutions. It's as simple and quick as that.